Good morning. In this lecture video, we are going to cover a topic called Ohm's law, which is from chapter 1 DC circuits. In this lecture, we are going to see what is an Ohm's law, the formula for a Ohm's law, and we are going to apply Ohm's law at different voltages, and we are going to see a couple of problems on Ohm's law. And finally, we are going to draw a graph between the voltage and current for a simple resistive circuit excited with a DC supply. Moving on to the definition of Ohm's law. Ohm's law states that in an electric circuit, the current passing through material is directly proportional to the potential difference across the element across potential difference across them. So to understand this, let us consider an element. Let's suppose say the element be a resistor, which is a basic element in an electrical engineering, and let R be the resistance of this particular element. Let this resistor is connected across a voltage source connected across a DC voltage source V, and let assume due to this voltage source a current I is flowing in the circuit. To measure the current, what I have to do is I have to connect an ammeter over here. Ammeter is a meter which measures the current. I connected ammeter to measure how much current is flowing. In order to measure the voltage, I have to connect one more meter which measures the voltage. That meter is called as a voltmeter. So I connected a voltmeter across a resistor. Now let's suppose say I applied a V1 volts. For that V1 volts, let the current be I1. I1 can be any numerical value. In the next instant, if I increase the voltage value to V2, then we can observe that the current value is also increased to I2. So if I go on increasing the voltage value, current value is also increased. So from this observation, we can conclude that if I go on increasing the voltage value, current value increases. So we can say the current in the circuit is proportional to the voltage. If you add the proportionality constant, we will get a final expression I equal to V by R. We can rewrite the equation as V equal to I into R. Now what is a V? V is the voltage across the element and I is current through the element and R is resistance of the element, which means we applied Ohm's law on the resistor R. We can rewrite the expressions as V equal to IR, R equal to V by I. Let's suppose say in future you came across a complicated circuit. Let's suppose say this is a circuit, this is a one more element, an inductor, or after that we have a capacitor, then we have a suppose say we have a transformer and a pretty complicated circuit. At the end we have a resistor. At the end we have a resistor. A pretty complicated circuit. If someone asks what is a current through the resistor, or if someone asks what is a voltage across this particular resistor, means the expression for voltage V equal to I into R, where I is current through the element which is a resistor and R is resistance of the element. If you know the current flowing through this resistor and resistance value of this element, then you can easily find the voltage across this particular element. No need to know this voltage, no need to know this resistance value, no need to apply mesh analysis or nodal analysis, no need to apply any type of complicated analysis. Similarly, if someone asks what is the current flowing through that particular resistor, the expression will be I equal to V by R. To get the value of a current flowing through that particular element, which is a resistor, we need to know the voltage across the element. What is the voltage across this particular element? You can calculate the voltage by simply connecting a voltmeter practically, taking the values, and then as it is a resistor, practically we are going to use a color code or different techniques to find the resistance value and calculate the current through the resistor.